3.0 mole concept with subtopic 3.2 empirical and molecular formula. In this subtopic, students should be able to define empirical formula, molecular formula. B. Students should be able to determine empirical and molecular formula from mass composition and combustion data. Definition of empirical formula. Empirical formula can be defined as a formula that shows the simplest ratio of all elements in a molecule. Meanwhile, molecular formula can be defined as the formula that shows the actual number of atoms of each element in a molecule. The relationship between empirical formula and molecular formula is molecular formula equals to N times with empirical formula. We look at, for example, 1. Determine empirical and molecular formula from mass composition. Question. A sample of hydrocarbon contains 85.7% carbon and 14.3% hydrogen by mass. Its molar mass is 56 grams per mole. Determine empirical formula and molecular formula of the compound. So in this equation, there are two elements, carbon and hydrogen. First thing, we must make assumption. We assume mass of hydrocarbon is 100 grams. And then we draw table with heading element. We use element carbon and hydrogen. Okay. Mass of carbon is 85.7. How we get 85.7? How we get mass 85.7 is 85.7 divided by 100 times with 100. So we get 85.7. Mole is mass divided by molar mass. The molar mass of carbon is 12, so we get 7.142 mole. While for hydrogen, 14.3 divided by molar mass of hydrogen is 1, so we get 14.3 mole. The next step is simplest ratio. In the simplest ratio, mole that we have been calculated divided by the simplest mole. Mole is 7.142. So for carbon, 7.142 divided by 7.142, we get 1. While for hydrogen, 14.3 mole divided by 7.142, we got 2. So the empirical formula is CH2. Next, we find the molecular mass. Before we find the molecular mass, we need to calculate empirical formula mass of CH2. So, carbon molar mass 12 times with 1 atom. Hydrogen we get 2 atom times with molar mass. Hydrogen is 1. So, the total empirical formula mass of CH2 is 14. Okay, the relationship molecular formula is equal to N times with empirical formula. So, we need to find the value of N. N equals to molecular formula divided by empirical formula. Molecular formula have been given in question, which is 56 divided by empirical formula is 14. So we get 4. And then we can substitute CH2 times with 4. So the molecular formula is C4H8. The next example number 2. In how to determine empirical and molecular formula from combustion data. The question, 0.974 gram sample of compound A is composed of carbon, hydrogen and oxygen was burned in excess of oxygen, producing 2.464 gram of carbon dioxide and 0.432 gram of H2O. Determine empirical formula of the compound. Okay, in the simple word, the equation us to determine empirical formula of A, which is A burn in oxygen, produce carbon dioxide and H2O. So the first thing, how to answer this question, from the carbon dioxide, we can find the mass of carbon. While from the mass of H2O, we can find the mass of hydrogen. How to find mass of carbon? First, we find mole of carbon dioxide. Mass given 2.464 gram divided by molar mass 44 gram per mole. We get mole 0.056 mole. And the next we do stoichiometry. 1 mole CO2 contain 1 mole of carbon. Mole carbon dioxide we have calculated is 0.056 of carbon dioxide contains 0.056 mole of carbon. Next, we can find the mass of carbon by times with molar mass of carbon, which is 12. So the answer is 0.672 gram of carbon. Next, we find hydrogen. So find the mole of H2O. Mass of H2O is 0.432 divided by molar mass of H2O, 18 gram per mole. So we get 0.024 mole. And we can see 1 mole H2O contain 2 mole of hydrogen. Mole H2O calculated is 0.024 times with 2 and we got 0.048 mole of H2O. Next we find mass of hydrogen 0.048 mole times with 1 gram per mole, we get 0.048 gram of hydrogen. So we can see mass of carbon, hydrogen and oxygen for sample A is 0.974 gram. Carbon we have been calculated is 0.672. Hydrogen mass 0.048. So we can find the mass of oxygen by minus 0.0974 minus with 0.672 minus with 0.048 gram. So we get 0.254 gram. And the next we draw table with heading element carbon, hydrogen and oxygen. Mass of carbon is 0.672, hydrogen 0.048 gram, oxygen 0.254 gram. Mole is mass divided by molar mass. For carbon divided by 12. Hydrogen we divide with 1 gram per mole. Oxygen divided by 16 gram. Okay, so we can see mole of carbon 0.056, hydrogen 0.048 and oxygen is 0.016. So the smallest number of mole is 0.016. So 0.016 can be used as a common factor for the simplest, to find the simplest ratio. For example, carbon 0.056 divided by 0.016, we get 3.5. Hydrogen 3.0. Oxygen 0.016 divided by 0.016, we get 1. Okay, from the simplest ratio, we can see carbon, we get 3.5. So, do not simple to round off 3.4 to be 4.0. Okay, because we need 2 times with any number to get whole